Hello, this is Mary Chibb with Bentley Systems. I was recently asked about adding clips to the parametric glass railing panel, so I'm just going to quickly show you how I set that up. I am in my Railing Panels project cell library, and I've created a copy of the parametric glass panel model. That much will be the same. Now, I did debate whether to add clips to the post cell or to the panel cell, and either would work, but I wanted the ability to have the clips adjust their height based on the height of the glass panel, which is why I decided to add them to a parametric panel. I'm going to start by creating a 2D profile that defines the shape of the clip. Now I want that profile on my default level I am using for the constructions. So a quick tip, if you hold the Alt key and then select an element that has the symbology you need, it will change the active attributes to match. Now I will use the Smart Line tool to draw the shape I need for the clip, making sure I am drawing in the same plane as the construction shape for the panel. Dimensions are not important at this point. Next, I will auto-constrain the shape. Note it constrained two sides to be perpendicular, two sides to be parallel, and created tangent constraints at the arc. This works fine if I intend to keep the clip perpendicular to the post, which I will do, meaning that even in a case where the panel is angled, like on a stair or a ramp, the clips will be perpendicular to the post. Another alternative might be to let the clip rotate with the slope. It just changes the constraints a little, and I will show that at the end. Next, I will dimensionally constrain the clip. I will start by using the By-Element tool to constrain the radius of the arc. Now, the cut sheet of the clip I am looking at has a total diameter of 45 millimeters, so that means a radius of 22.5 millimeters. Next, I will dimension the total length of the clip. Now, the cut sheet shows this at 67 millimeters, but I'm going to make it a little longer so that it will actually overlap my post just a bit. It won't show in the final railing, and I can avoid any gaps if I have a round post, for instance. So I will use the distance tool and define a distance from the outer edge. Now make sure you are selecting the line and not a point on the line. And then select the arc. This time do select the midpoint of the arc, the furthest point from the line. And I will set this dimension to 75 millimeters. So that defines the clip itself. We will constrain it to the panel later. First, we will create the 3D geometry. So I'm going to set the family and part to Specialty Interior Material Chrome. That resets my active attributes, but I do want to make sure I set the class back to primary. Now I will switch to the Solids tab and select the Extrude tool. Now my cut sheet says the clip is 30 millimeters thick, so I'm setting the distance to 15 millimeters since I will extrude in both directions. I select the profile and extrude the clip. Now I always like to double check at this point and turn off constructions just to make sure I have the geometry correct. Looks good, so I will turn constructions back on. Now that the clip is created, I will copy it to the other four corners of the panel. And then constrain the clip to the panel. I will start by constraining the edge of the clip profile to be parallel to the vertical edge of the panel. And since the clip edges are constrained perpendicular, that will keep the clip from rotating when the glass is sloped. So I will go back to my Constraints tab and use the Parallel constraint. Select the vertical edge of the panel construction first, then the vertical edge of the clip construction. Next, I will create a couple of dimensional constraints to position the clip relative to the corner of the panel. I'll use the distance constraint to set the distance between the vertical edge of the panel construction and the center of the arc. I am setting that to 22.5 millimeters. I will use the distance constraint again to set the distance between the upper corner of the panel and the top edge of the clip. In this case, make sure you dimension from the corner vertex of the top edge of the panel. The top edge of the panel may be sloping in some cases, so you do not want to set a dimension between two lines that may not be parallel. That should position the clip relative to the panel. Now I just need to repeat for each clip. Now let's test this by changing some of the panel variables. So if I change the height of the panel, the clips should move accordingly. And if I change the length of the panel, the clips should move accordingly. And if I change the angle, the clip should remain aligned with the vertical. That is all working, so I think we are done. Now I did do an alternate in which I created the clips so that they would actually rotate with an angled panel. So let me show you the difference in how I constrained that one. So let me change the angle. And you can see here that the vertical edge of the clip remains vertical, but the rest of the clip rotates to match the slope or angle of the panel. So let's take a look at the constraints. In this case, I have constrained the vertical edges to be parallel, but I've also constrained the top edges to be parallel, and I removed the perpendicular constraint that was on the corner of the clip profile. Other than that, the constraints are the same. If you have any questions or comments, please leave them in the comments section below. Thank you.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.